for watching. I'm working more on my stock market project today. Before I get started, I'm going to review the goals for the project, the progress I've made so far, what I've done recently, and what I'm going to be working on today. I work on this every day, so if you're interested in stock market models, Python, AI coding tools, or just markets in general, please like and subscribe to follow along on this journey. So let me go up here and show you what my goals are. So the first goal, beat the S&P 500 by a significant margin and make money in all regimes. So if the whole market's going down, I want to still be making money. If the whole market's going up, I want to be doing way better than the S&P 500. So basically, otherwise I could just buy the S&P and sit on it. My second goal is to create a usable Python tool. So I'm writing all this code in Python. I'm generalizing the code to make a tool that anyone can use. And when I'm exploring the model, I'm doing all of it here in this model explorer file. And I'm calling the code that I've written. So basically anyone can do the same thing and make the same sorts of models that I'm doing. And you can do that in under 50 lines of Python code. So we have basically data going back to 2011, but you don't want to use all data. So there's all sorts of things that are going to make the model perform worse. So rather than use all data, I'm isolating a stock universe, and then I'm using that to train a returns model. The returns model is predicting things like returns or probability of positive return or returns relative to the market, things like that. And then once I have a really good returns model that's performing well on all of my metrics, I'll go over the metrics I'm looking at in a second here. Then I'm going to plug that into a portfolio model, which is going to decide how to allocate money based on the output of the returns model. So this is the, I started this at the beginning of the year. This is where I got to at the end of January. So I started out using NASDAQ data. I should say here that one of the requirements I have for the second goal is I want to create a usable Python tool that anyone can use to create advanced models. But a big constraint I have on this is I want everything to be free. So I think that's kind of not going to be very useful for people. If I make a tool that you have to plug an API into or something, people don't want to pay for things when they're just starting off. At least I'm just talking from my own experience. If I find some Python tool that says, hey, you can create your own models, but you have to, plug in this API and be paying for this API, I'm going to be hesitant to use it. One, because I'm broke, but two, because I don't want to spend money on something that I'm not positive is going to work. It's going to take basically a lot of research to get a usable model. And does anyone really want to spend a lot of time doing research while they're paying for data? Professional quants do, but normal people who aren't used to the stock market but have some Python skills probably don't. So I want to make it basically lower the barrier for people creating the model. So since I'm using free data, the first most obvious thing was just use NASDAQ data. They have CSVs for every ticker you can download for every day. Now this is nice, it's useful, but it's going to be a big pain in the ass to go down and write some code that's pulling all of those CSVs every single day, or something like that. And so I found a better data source here on DoltHub. Where is my dog is whining? Buddy's whining. Where are you, buddy? Oh, are you whining or are you just enjoying your bone? So, what was I saying? Basically, yeah, so I found this better data source. The link's in the description if you're interested. I also have a link to my GitHub in the description. And I have instructions on there for installing this on your computer. And I have some scripts I wrote for kind of manipulating the data into something you want. And then if you use those scripts, you can use the rest of the code, which is going off of this data. So this is an example of fundamental data. I was just comparing how different stocks did over time. These are the big beverage companies, Pepsi, Coca-Cola, and Keurig Dr. Pepper. Comparing their Dr. Pepper, comparing their fundamental variables over time. And then I did a similar thing for price. You can compare any stocks in a sector. In this case, it's the pharmaceutical sector. and kind of see what's underperforming or overperforming the sector. So this is kind of useful stuff, but it's not really useful for automating anything. And since I want something that's automated, I just want to run a script every morning and have it adjust my portfolio allocations accordingly. I need something that's going to be work well with that. So you want a learning model. I'm using a light gradient boosting method. This is very common for stock data. It works really well on basically time series data, large data sets that require a lot of features. So in the stock market, you have a really high or really low signal to noise ratio. And so you're going to need a lot of features, you're going to need a lot of data, and it's handling missing values really well. And so a feature of stock market data is sometimes you have missing values. And finally, it works really well on time series data, which obviously I have. So for those reasons, I'm using a light gradient boosting method. I then incorporated, and the best I was able to achieve on this first iteration in January was about 51.5%. That's pretty good. Not great though, and so but better than a coin flip. So I implemented this into a portfolio strategy to try to see if I could find something that worked well. I did find something that worked well, and so if I analyze the Sharpe ratio versus number of positions, the only one that has a Sharpe ratio above 1 is if I'm picking one stock per day. So you want a Sharpe ratio above 1. That's kind of the bare minimum to have something that's going to be useful in the market. And you see here it's outperforming the S&P 500 pretty substantially. So it seems at first look like that's hitting my goal. However, this is slightly different. This one's predicting probability of going up. So I tried thresholding it to see can I squeeze out better performance. And you see the Sharpe ratio. This is on the Sharpe ratio is on the y-axis. The probability threshold I'm using is on the x-axis. So I was looking at if I change the threshold, can I increase the Sharpe ratio? And I found that I increased the Sharpe ratio substantially. But the problem is, if I increased it above 54%, 54% here is returning over 2.5 for the Sharpe ratio. Really good. But if I increased it a little bit, if I increased it to 55%, it wasn't picking anything. And so for that reason, and also because it's only picking one stock per day, I drew the conclusion this is a really fragile model. No matter how much time I spend on the portfolio strategy, if the base model isn't good enough, it's not going to give you positive returns. Rather than keep working on this, I decided to focus on the model itself, and I wanted to iterate through a bunch of features and targets to get a really good model. The problem was how I had the code base organized at the end of January, so it was basically a big mess. I needed to write a new script every time I wanted to change how the universe is defined, change how the model trains, and change the portfolio strategy. So it was already at dozens of files. It was going to quickly blow up into hundreds of files. It was going to be cumbersome for me to use and impossible for anyone else to use. The next thing I really had to do before exploring model improvements was reorganize the code base. So that's what I did here. This is the new code structure. So I have clean data already, and I created some filter classes. So basically you can filter out the universe however you want. Like I said, you don't want to just include everything. Fed these into the stock universe class, so that's its own Python class. And then the stock universe I feed into the returns model. I made a bunch of feature and target classes and a general class called feature engine for pulling the features and targets into the data set. And so this is really diverse. You can define feature requests, I call it. Each of those takes one line of code. And then once you've defined all of your feature requests, you can put those into the returns model. And then the returns model is its own class. And it has some functions that can basically you can split the data, run the model, and test the model every which way you want to. And these are all the features I implemented. This is what took most of the time. But I wanted to have every single feature and target I could possibly want for price data only. I decided to start on price data so that I could go through the model exploration. So once I had the code reorganized, the next step was just plug all the features into the model and see how it performs. And it was actually performing worse than before on a directional accuracy basis. But it turns out directional accuracy isn't really what I want to use. I'll get to that in a second. This is something interesting I found, which is kind of a property of stock market models. So since the signal to noise ratio is really low, the further out you're looking into the future, the better it performs, because the higher the signal to noise ratio gets. So if you're just trying to predict returns for one day, buy at market open, sell at market close, or buy at market open, sell at the open of the next day, that's pretty hard to predict returns, because there's a lot of noise that happens day to day in the stock market. However, the further out you're looking, the more signal there is, and so you're getting better performance basically. So this here I showed that if I'm just using daily log returns, you see here it's getting over barely 50% accuracy, basically a coin flip. And that's because there's so much noise. If I do 5 days in the future, 52.5% accuracy. 10 days in the future, basically 53% accuracy. 30 days in the future, 54. So basically, the further you're looking out into the future, the better performance you get on your model. Um, and here I found a really good model. Where is that? Right here. So another thing I'm looking at is the decile analysis. So if you take the returns, split them into deciles, and then look at how they perform, you see that, or sorry, take the predictions, split them into deciles. It should look kind of like a staircase, and that's roughly what you see here. That looks pretty good. And also I'm looking at these metrics. So rather than just look at the directional accuracy here, I want to look at the information coefficient. That's giving the predictive power of the model. And then the other things I'm looking at, standard deviation, the information coefficient to information ratio, both on a daily and annual basis, and then the t-statistic. These are telling me the stability of the model. So you don't want something that's really powerful in predicting, but it's unstable, because sometimes you're going to have really big drawdowns. That basically means when it's wrong, it's really wrong. But also you don't want to have something that's really stable, but doesn't have a lot of predictive power. So you kind of got to balance those two. And here I'm beating every one of my goal metrics. I went through and tested it every which way I could think of testing this. And you see that no matter how I tested it, it was performing really well. I tried adding some new features. Those weren't working because those were macro features, and I'm normalizing the features in target to the market average. But what? Oh yeah, by the time I finished my tests, I found here, so this was 2 weeks ago, I found here that actually the model is beating it on every metric. It actually improved after I ran the tests and incorporated everything to make sure I'm not overfitting and stuff. The performance I was getting out of the model was even better. So at this point, I was really confident. I thought, okay, I have a really good model. I'm ready to implement. However, I tried splitting the data differently. So I went from splitting so that the first 60% of the data set's training, the next 20% is validation for tuning the hyperparameters, and the final 20% was for testing. That was the results where I was getting really good results here. So I changed it to train on the first 50%, validate, tune the hyperparameters on the next 15%, and test on the final 35%. And the model went from beating every metric to underperforming on every metric. So the question is, why is this happening? There's a few reasons. One, it has less training data, so the model's going to be worse. Two, it has less validation data, so the hyperparameters are going to be worse. And three, it has a lot more test data. So 35% of the 15-year data set means that it's basically testing on the final 5 years, and the market changes, patterns in the market change. So what it's learning from 2011 to 2018 that makes it perform well is very well could be different from the patterns that are happening in the market over 2021 to 25. So the way to test this is a walk forward analysis. I grouped the data into sets of 6 years sequentially. And so the first 4 years were the training. The fifth year was validation, tuning the hyperparameters. And the last year was testing. So for example, 2016, the first year here, it's trained on 2011 to 2014. It tuned the hyperparameters on 2015. And then this is the results for the test on 2016. And so you see I'm shooting for 0.01 to 0.02 for the information coefficient. and you see that I'm outperforming my goal for the information coefficient on every year through 2021. However, it falls off in 2022. It slightly improves to be barely above the threshold in 23, falls off again in 24, barely improves in 25. And you can see here kind of the same pattern is evident. So this is information coefficient to information ratio. Um, and you see here that the performance falls off as well, just like on the information coefficient. However, even though it's falling off, I'm shooting for a value of 0.3 on this metric, and so it falls off significantly. You can tell the model's getting worse over time. However, it's still hitting the threshold, and actually 2022 was the low, and it improved every year. And so there's a couple. Basically, I need to dig into this, and but basically this is showing that the model's not bad. I just need to squeeze a little bit more performance out of it. One thing that's interesting is you see, so the information coefficient got way worse in 22, and the information coefficient to information ratio got a lot worse. 2022 was a recession. The market went down basically the whole year. So this is a little concerning. I need to look into that, and I need a model that's going to be robust for recessions, because it looks like we're headed into one. So I tried, the first thing I wanted to do was add sectors to the model. So this would help the model in a couple of ways. One, it lets you add sector features. So this is a new feature which is uncorrelated to the other features. That should improve the model. And then additionally, instead of normalizing to the market average, I can normalize to the sector. So that's what I've been working on basically the last week. It took quite a while to pull the sector data. I finally got it working. However, when I added it as a feature, it didn't work well. It degraded the performance of the model, and the model was performing even worse. I tried, oh yeah, so this is the documentation of that here. And so the next thing to try was neutralizing the target to a sector. That made it worse. I tried neutralizing the target and the features to the sector. That made it worse. And I tried neutralizing just the features and not the target to the sector. That made it worse. And so adding the sector information degraded the performance of my model. It didn't make it better. I tried, so earlier when I was doing shadow feature reduction, the different feature reduction methods I was trying, I was implementing those incorrectly. So I tried doing that again, and that made the model worse. I tried earlier this morning, I tried constraining the universe. So this took quite a while, but this is what I did in the stream earlier today, was basically there's all sorts of stocks. These stocks here are the ones I want. Common stock, ADR, that's basically a foreign stock that's listed on the US stock market. And then real estate investment trusts, those have useful data. However, these other stocks, ETP, equity, WRT, I'm not even sure what those are. Closed-end fund, unit, right, MLP, royalty trust, all of these are going to make the model perform worse. I know for sure these test tickers are fake tickers that the NASDAQ can use to test. And so you don't want to include those because those never change price because it's a test value. And so I tried removing all of this stuff from my model, and that actually made it perform worse. Oh, this was a different universe. So I tried constraining the universe more to see, maybe if I change around how I'm defining the universe, I can improve performance. That didn't work. And then I tried removing all of those tickers from the model, and that gave worse performance. So now the problem I'm working on is, basically how do I improve performance? You see the decile analysis here looks really bad. So today on this stream, I'm working on this stuff to try to improve the model. Yeah, so that's basically that. So let's get into it. So what do I want to work on today? Obviously, I want to add fundamental features. That should improve the model. It's going to be pretty hard to get those. But let me see real quick because... so earlier the problem was I wasn't getting fundamental features for all of my stocks, but like most of all of these that are I removed here, actually don't have fundamental features. And so I wasn't able to incorporate fundamental features in my model because there were a lot of tickers in my universe which didn't exist in the fundamental data. And so now I want to look through and see, is that because those stocks were in the data? Because they're not going to have fundamental features. So let's go look. Oh, import pandas as PD. Import pandas as PD, and then we'll say df is equal to pd.read csv, and I forgot, what's the fundamental data look like? Yeah, let's pull that up really quick. So in the data folder we have, let's make it a list and sort by kind. So oof. Let's sort by date modified. So most recent stuff, fundamentals, here we go. So all fundamentals.feather, and then all ohlcv.feather. Oh no, then the universe. So so instead of calling it df, I'll call it u for universe is equal to pd.readFeather, and we're going to read /data /universes/4.feather. And then f for fundamental data is equal to pd.readFeather, and let's go to /data. Hey man, hey, thanks, bless you too. Why are you saying that? Because it's Sunday now? Sunday, isn't it Palm Sunday? The Sunday right before Easter, isn't that Palm Sunday? So we're reading in the universe. Now let's read in the data, the fundamental data. So that's in quarterly fundamentals. Quarterly _ fundamentals .feather. Okay, good, we have those. So then we'll say, so I want to see u.account. It's for trade. Well, I guess both. Really, I would say I'm basically trying to make an automated model, which will automate portfolio allocation. So I just want to run a script every morning and have it adjust my holdings accordingly. So I'm doing analysis, but my end goal is to do trading. But I have another end goal, which is to generalize the code so that anyone can do this for themselves. So right now, where are my goals? Here are the goals. So the second goal is to generalize the code. I want to make a tool in Python that anyone can use to implement stock market models. So this is kind of the layout for the model. I haven't incorporated this portfolio model step yet because I'm still working on the returns model. I went over that at the beginning of the stream, where I'm at on the returns model. So go back to the beginning if you're interested in that. But basically, I'm working on this to squeeze out better performance. Yeah, I'm doing machine learning. I'm using a light gradient boosting method. That works really well on time series data, works really well on big data sets, works really well on if there's missing values. And so for those reasons, it's really a really popular model to use for quantitative analysis. Handles a lot of features really well. And so these two steps, isolating a stock universe and then creating a model, I also have code for like robustly testing the model. You can do feature selection to drop out features that are highly correlated. There's all sorts of things. You get this output when you run the model, so it tells you how it's performing on every interesting metric. If you watch the streams, you'll know what metrics you're shooting for. So information coefficient should be above 0.01 to 0.02. Standard deviation should be 3 to 13 times the information coefficient. The information coefficient to information ratio, I forget what it should be daily, but it should be at least 0.3 on an annual basis. And then the robust T statistic should be above 1.98. Hey, Krishna. What is my workflow? That means like my process, or you mean how the model's going to work? This is the structure for the model right here. So yeah, basically I have data. I'm creating some filters. There's each one of those is in a class. You can feed filters into a universe. This is its own class, and it'll get the universe for you. You feed the universe into the model and feed whatever features and targets you want into the model, and then you run the model and you get this output. And so currently, the good thing about the code is you can do all of this in under 50 lines of code. You can do really robust testing, and you can be really confident there's no things like survivorship bias, look ahead bias. You can implement things like a walk forward analysis. You can cut up the data to training data, testing data, validation data. You can do all of that any which way that you want. If you're interested in that, you can get the code here. Let's see, here it is, stock market tool. So you could go download this. There's instructions here on how to use it. I would appreciate if you downloaded it, tried it out, and let me know how it works. Let me know what I can do to improve it. Let me know what you'd like to see incorporated into the model. It also helps me out a lot if you star the repository, watch the repository, and follow me on GitHub. That helps raise my coding profile, helps me get freelance gigs and coding jobs. Also, just subscribe. That helps me out, of course, too. Subscribe if you're interested. So I work on this every day. I'm slowly making progress. Once I get a really good model and portfolio strategy working, I'm going to start paper trading this. So I'll update the progress on how the paper trading's going, basically to keep me honest. You guys can, know if the model's losing money or making money. That's like should prove whether it's legit or not. And then if it's successful on paper trading for a month, then I'm going to incorporate it and start using real money. So those are kind of the goals. Right now I need to work on improving the model. Yeah, so that's what I'm working on today, is improving it and getting something that works really well. But all that to say, yes, I'm using machine learning. And so right now, so all the features I've incorporated, these features here are all on price data. Now this is like a really basic model, but I had concluded that I can't use fundamental data because there are tickers in my universe which aren't included in the fundamental data. However, I went through and earlier today I wrote some filters for the universe, which is removing all stocks that aren't common stock, foreign listed stocks, or real estate investment trusts. And so all of those, I'm not sure about the foreign stocks, but the common stocks and real estate investment trusts do submit quarterly reports. And so I drew the conclusion earlier that I can't implement fundamental features because I don't have all of the data for fundamental features. But that's when I was including all stocks. So now that I've trimmed the universe down to only include some stocks, I want to see, am I able to include fundamental features? So that's what I'm seeing here. So basically I've pulled these two data frames. Now I want to see if all of the tickers that are in the universe data frame are all of them included in the quarterly fundamentals frame. But I always forget how to write this in pandas. So let me exit out of this. It's going slow. So I have two pandas data frames, U and U for universe, F for fundamentals, U and F. I want to make sure that all tickers, yeah, I mean, the whole thing's quantitative. Basically, this is a model for the stock market. Yeah, that's basically what it is. It's a quantitative model to predict returns on the stock market. Then the portfolio level is going to be basically a differential evolution algorithm I'm going to use to optimize a strategy based on the output of the returns model. But the first step, I went over this at the beginning, but I guess I'll go over it again. Basically, this is where I was at the beginning of January. I had a model that was giving about 51.5% returns. I found a strategy which is outperforming the S&P 500, so you can see that here. The problem is the only strategy with a Sharpe ratio above 1 was this one here with the 1, and it's 1 because it's picking one stock per day. So the problem is this is really a fragile model, and picking one stock per day isn't going to do well. I tried thresholding it and I found a really good threshold. So this is the Sharpe ratio. It's getting way above 1, 2.5. But the problem is if I increase the threshold by 1, it's not making any picks. And so these two things indicate it's really a fragile model. And if your model's not good, you can only do so well at the portfolio level to squeeze good returns out of it. And the problem comes back to this model. So before I get to the portfolio level, I really need to make sure that the model's performing well. And I'm trying to beat my metrics that I've listed here. So 0.01 to 0.02 for information coefficient is the minimum. I want to get standard deviation should be less than 3 to 13 times the information coefficient. Information coefficient to information ratio on a daily basis should be 0.02 to 0.03. So again, there's really low signal to noise ratio in the stock market. So the daily average is going to be low. On an annual basis, I want it to be above 0.3. This is the results from the walk forward analysis. So you can see it's missing the metrics in 22 and 24, and generally it's falling off for the information coefficient. So that gives the predictive power after 2021. And the same thing's happening with the information coefficient to information ratio. But if you remember, my goal metric is for this is 0.3. So even though it's performing worse and the performance is degrading on this metric, it's still beating the metric for every single year. So basically that shows the model's stable enough, but it doesn't have the predictive power that I need. And what would really improve the predictive power is if I could add fundamental features. So that's what I'm checking here. Can I add fundamental features into the model? So I have two pandas data frames, U and F. I want to make sure that all tickers in the account symbol column in U are also in F. Write a line of code which will do this. Oh man, I gotta crack my back. Okay, so depending on whether you want to check if it's true or filter the data frame to force it to be true, why would I want to force it to be true? Okay, so this is saying if all count symbols is in this guy. So let's see. False. So, okay, so it returned false. How do I print out all tickers which are not, which are in U but not present in F? Question mark. Okay. So let's paste that in. And let's see, what are the missing tickers? So not that many. Let's look at what these are. So these are in the universe data, but not in the fundamental data. The problem is I can't just drop these out and say don't train on these tickers, because that will create, I'm worried that will create some survivorship bias. So the question is, why are these not included in the data set? If it's something like they've been dropped out of the stock market, then that's going to be a real problem for me. If it's something like, oh, these are foreign listed stocks which don't have to report quarterly data, or they have to do some reports, but they aren't subject to the same requirements as the they're not subject to the same requirements as what's it called, American stock. So if you're an American company listed in the stock exchange, you have to report to the SEC every quarter, and they give you data that you have to report. You don't have a choice in the matter. If you're a foreign company, the reports you have to give are based on, whatever your local requirements are. Like a Chinese company, they have some other requirements. I don't know what the Chinese requirements are, but This is actually what's really good about the SEC. I used to think the SEC was bad because I used to think all government is bad, but now I see the SEC really makes it, it allows you to have confidence in the market, and they have all these free tools that are really great that allow you to do things like I'm trying to do. So I've become a big fan of the SEC. So let's see what these tickers are. What's KAVL? American company focused on incubating and distributing innovative products, primarily known for nicotine delivery systems. Okay. Whoa, so that's a really low price stock. So it's at 16 cents. Yeah, so I guess this is a shit stock. So initially, universe 4. So let's add another universe, which is universe 5. So I am filtering top 100 by volume. So this is probably included because it's being shorted. So afterwards, filter for prices above $5. So I'm doing that because you want you don't want to include penny stocks in the model. And then after that, I can get, let's say, top 500 by volume, because 100 isn't a lot of tickers. So let's exit out of here. Oh no, I guess I'll change universe 4. I should keep that because I'm documenting it in my code. So we're gonna say 5, same. Okay, so let's take this out, take that out, and take this guy out. Okay, so afterwards filters, yada yada yada. 5 is same as universe 4, but drops out stocks under $5 before volume filter. Because yeah, you're gonna have really high volume on things like this stock because it's being shorted. But that doesn't mean that it's I could just exclude that because that's going to be really easy to predict. So I don't think I need to worry about fundamental data for that. So let me run this universe really quick. So that's universe 5. So this is universe 4. I'm just going to put this down here and say universe 5, and then I'll add the changes that I want to make. So top liquidity filter. Oh, so not top 100. It's doing top 1,000 by volume. Yeah, but drop stocks less than $5. So we'll add in here the price filter. Let me make sure I'm naming it right. So here are the, this is what's really great about the code is if you want, I have this general feature class, and then anytime you want to add a new feature that does something else, you can add it in. All you have to do is write a class. So like this one here is, and then all you need in the class, you need some way that you're initializing it, and then you need this apply function that will apply the filter to the universe. And so like you see here, that's like 26 lines of code. The classes are really easy to implement. So let's add this security type feature. Oh no, I have that. I'm already adding that. Let's add price filter. So price filter, min price is $5. So this is gonna filter out all stocks that are under $5. At the close of the previous day in the data set. So let's say min price is equal to $5. Put a comma there so it's a list. And let's run this universe. Okay, now I want to go through, oh no, don't do it here, because then I'll lose these tickers. So I guess I'll just put these into a text file real quick. So let's open up a new text file and put those guys here. And now I'm good to run the code. Let's make sure it's running universe 4. Oh no, stop the code again. So I don't want to overwrite my universe. So this is going to be universe 5. And then call this get universe 5. And then up here, we'll add a new Boolean for the universe, get universe 5 is equal to 1. So I'm turning that on. And now we're going to run that logic. Get a new universe, save it as 5.feather. So now let's look through those tickers and see what's the deal with those. So that one was obviously just really high volume because it's being shorted. The question is, why did it not have a quarterly report? So does KAVL issue quarterly reports? Question, it is not in my data for quarterly reports. What is the reason for this? It is not in my data. Does KAVL issue quarterly reports? It is not comma space, but it is an American company. What is the reason for this? Okay, so now we want to figure that out. And then the next ticker to look at is, so we have KAVL. Let's also look at MDLN. Medline, headquarters, Illinois. Okay, so another American company that I don't have fundamental data for. Let's see what it says. So it's thinking, yes, they legally issue quarterly reports. They legally issue, as opposed to illegally issue quarterly reports. It is almost certainly because your data provider automatically filtered them out based on their specific corporate situation. They were delisted to the OTC in late 2025. KAVL faced severe compliance issues. The stock dropped to pennies, and NASDAQ formally issued them a delisting notice. As of early 2026, trades on the OTC Pink Limited market and has a microscopic market cap. Has a microscopic market cap, but I was getting it in my volume filter. Okay, so now we want to do the same thing that we were doing before. So import pandas is PD. Let's pull the two data sets. So universe is now 5.feather. And then the fundamental data is the same. And then let's get the missing tickers, and then let's look at them. So this filtered out basically nothing. So the problem with KAVL, all right, so MDLN isn't in there either. Why? And let's get out of here. Let's run a new universe. So universe 5. So we're getting bottom or top 1,000 by liquidity. What if we change that to just get the top 500 by liquidity? So that's going to remove some stocks. So maybe I could just run that again. Maybe that'll fix it up. Maybe it won't. What BC is that? Because the search into the search results indicate that MDLN is Medline Inc., a massive medical supplies company. Oh, that recently completed its IPO. In mid-December 2025. So they just haven't had a quarterly report yet. Okay, so that makes sense. Let's look at the next one. What about SOLS? Let's pull that text file back up. Yeah, so if you just tuned in, please subscribe and like the stream. That helps me out a lot. I'm putting all the code, so I have two goals for this project. One, I'm making a quantitative model so that I can make money from the stock market. The second goal is to generalize my code so that anyone can get money from the stock market. If you're interested in that, you can get the code here. This is the repository, so download it, check it out, see how it works for you. You can isolate a universe from your data. I have scripts to get all of the data and instructions for getting the data on your computer here in the README. So you can get all the data onto your computer. You can isolate a universe from the data and train a model on the data and test it in all sorts of different ways, like a walk forward analysis. You can look at the information coefficient, standard deviation of the information coefficient to information ratio. I have 3 different methods for trimming the features. And so, yeah, you can do all of that in under 50 lines of code. So if you're interested in that, download it, try it out, and let me know how it works. Let me know how I can improve it and what you would like to see added to the code. If you find it useful, please star it, watch it, and follow me on GitHub. All those things help me out a lot. Helps raise my coding profile, helps me get freelance gigs and coding jobs. All right, so let's ask it. Report back for each of these tickers, which aren't in the data set. And then let's remove the first few. Report back for each of these tickers. Okay, here are the tickers. And we already looked up these guys. I'll add a note here. Man, why is this going so slow? None are in my data set. Come on. What's it doing here? Oh my god, why is it writing all of this code? Whoa. What? This thing's spazzing out. Look at this. I am done thinking. I will respond now. No additional tools needed. No further modifications. Execution complete. Final check of tone and clarity. End. Bye. What is it doing? Done. Writing. Finished. Ready. Go. Wait, I'll use this separately in a sentence if needed. What is this? Peace out. End of thought. Seriously, ending now. This thing's spazzing out. Stop it. Okay, well, what the fuck? This is very weird. Can I get down to the bottom? Okay, let's cancel out of that. Let's go to Claude. Okay, so I got the new universe. So now let's go in and look at that again. So now we're going to see how many missing tickers do we have now. Do we have less than before? Do we have any? Okay, so that's the universe data. This is the fundamental quarterly reports. These are the missing tickers, and then let's look at them. Oh, there's a lot fewer. C1.A, what is that? Okay, so it's not because they just had their IPO. Yeah, so I need to figure this out. So this is nicer. All right, so I don't know why MDLN's in, or MDLN, we know why it isn't in the data set. Let's look up SOLS. SOLS. So they have, that's not a penny stock, and it's not that it had recently had an IPO, so I want to know the reasons. This is taking a while. Come on, hurry up. Okay, it was spun off from Honeywell as a brand new entity. It has no quarterly reporting history. Okay. This IPO'd. Okay, so MCTR IPO'd in January 2025 and changed its name. So I guess that's kind of like an exception I could leave out. Ceased trading following market close in 24 after it merged with SiriusXM to form new SiriusXM under the ticker Siri FER Ferrovial SE is a Netherlands-based infrastructure company. As a foreign private issuer, it files 20F annual reports with the SEC rather than 10Q. Okay, so no quarterly reports for FER. Announced as a strategic rebranding with Clotho Neurosciences in September 2024. McAfee became privately held. I mean, these aren't very many tickers. Quantum computing. So what if I add more filters? So price filter, top liquidity filter. Let's add an advanced stats filter. Here. And let's add min history days 252. Max crash. Forget about that. Don't require an uptrend. So we're getting the top 500 by liquidity. Then let's get the bottom 500 by volatility. Bottom, yeah, we'll do bottom 500 by volatility after getting the top 1,000 by liquidity. Okay, so exit out of this. Let's run the universe again. Get that. Okay, so earlier I tested. So there was that model I was getting, which was working really well. Where did my PowerPoint go? So I had this model was working really well. It turned out it was only with the certain training, the data split I was using. So I want to compare to this model. And earlier today I looked at, if I filter out all those stocks which are going to make it worse, how does it perform? And obviously it performed worse. This looks like a really bad model. It's not stable in any sense. It's not powerful in any sense in terms of its predictive power. So I need to improve it. And so the question is, why did this perform so much worse? But this was using different filters than I was initially using. Initially, I was getting, isolating, doing everything here. So getting the 3,000 top highest volume tickers, and then dropping out everything. So dropping out everything that's not one of the top 3,000 by volume. And then I dropped out everything that was under $5, dropped out everything that had a crash of over 50% in the last year, and then out of the remaining stocks, I kept the lowest 1,000 by volatility. So I'm going to do these filters and see how the model performs, because when Universe 4 I'm just dropping out the securities that I don't want and then getting the top 1,000 remaining by liquidity. That performed worse. But, you know, it could be that these other filters are important. So let's put the filters down there, and then I'm going to copy this. Put that right there. I'm going to call this get universe 6. And then put the filters in. And then 2 filters we're going to add. Before we do anything, let's filter out all the securities that we don't want. And the question is this going to perform better? So let's see. So this is basically going to be the same universe as 1, but it's not going to include the tickers I don't want. And maybe the order matters. But yeah, so let's do 6. This is same as universe 1, but drops out all ticker types I don't want, but I'll say keeps, removes everything not common stock, REIT or ADR before. So common stock, normal stocks like Apple or Tesla. REIT is real estate investment trusts, and ADR are foreign stocks that are listed on the New York Stock Exchange. So drops out everything that's not common stock before applying the filters. Okay. So that'll be the next thing I do, get universe 6. All right, so now let's turn get universe 6 on. Get universe 6 is equal to 1. So we're gonna run that. Don't want to save it as universe 5 though. So let's save it as universe 6.feather. Filter ETFs. Where do I do that? Universe 1. So when I'm doing universe 1 equals that, and then I'll say here also filter ETF. So that should already be filtered by the security type filter, but I just want to make sure. So filter ETFs is equal to true. Now let's run that. We're going to get that universe. Let's do it in here. It should be good. Let me make sure I saved all of this. Save. Yep, it was saved. Now let's go in and check what tickers are missing. So first, import pandas. Get the universe, so 5.feather. Get the fundamental data. And then what tickers are missing. And now let's look at missing tickers. So this is basically what I just did, but a little bit more restrictive. And there's only one. So what is that? LSXMK. So basically, if I can get a universe where all the tickers in the universe are included in the fundamental data, then I know that I'm good to go ahead and incorporate the fundamental features. And actually, I've already written code for that. So I have here a feature engine that's generating all price data features. And then I have here, let's close this folder. Close that folder, scripts, and we have fundamental engine, and this will generate these fundamental features. So I don't have everything incorporated yet, but that shouldn't be too hard to get that going. All right, so I only have one missing. Now this is getting the new universe, so I want to see how does it perform on this new universe. So I'll test that in a second. Let's go over here to Model Explorer. And I'm going to change the universe to 6 because that's the one that I just got. And then I'll test that. And then the question is what? Then I can go ahead and make a new model, which is using fundamental data. So And if this doesn't work at improving the model, the next step is I'm going through and I'm looking at all of the features and seeing, can I drop any of these out? Which ones are highly correlated? What are they telling me? And how can I improve the features? So 2026, we're almost done with this. So let's see if it's getting data for every year. Basically, this is running through all of the data and getting the tickers which satisfy the filters at the beginning of each month. So data retrieved, generating universe, start with 8,300 stocks. Security type trims it down to 6,000. Price filter trims it down to 4,000. Liquidity trims it down to 1,000. Advanced stats drops it down to 0. So what the hell is the deal with that? So that's not going to work. Let's go back to Universe Explorer. Advanced stats is dropping it down to 0. So when I give it 252 days of history, So let's remove that argument. I should have defaults to the argument, so that should be fine. Now let's run this again. So, what was just running? That was Universe 6. Oh, it's because I had them both turned on. So Universe 5 isn't getting anything for at least some months. So we know that will be good. That's the same problem I ran into here. And actually, I think there's a problem in my min history argument because I added that. That was drop out everything with less than 1 year of data. And once again, you see there's lots of months where it's not adding any stocks into the universe. So there's something wrong with the logic for that. But I'll just leave that out for now because lots of the features require a year of data. So the long-term features I'm using are looking back for a year. So it's already trimming out that year of data. So I don't really need to add that here. So I'll change min history days to none. But now it's going through, since I had both of those flags on, it's going through and doing the Universe 6. So I want to see how that performs. But the Universe 5 that I got here wasn't working. So how's the Hey, Paprika! How's the holistic universe coming? What do you mean holistic? I forget what holistic means. Like all enveloping, it means. Characterized by the belief that parts of something. Yeah, well, it's going well. I don't know. Did you watch the stream earlier today? I forget because they all blend into one. But I did find basically this step highlighted in green is done, highlighted in yellow is to do. And so I was thinking, if I drop out everything that's not common stock, so things like Tesla or I don't know, Apple, ADR, foreign listed stocks, so things that are listed in foreign markets, but there's basically a wrapper built around them, so they're listed on the stock market, and real estate investment trusts. So if I keep only those, how does the model perform? And here's the results. It performs very poorly. So it's worse on every metric. You see here the decile analysis, which should look something like this. That looks okay. Or this looks really good. Up here, there's like a perfect one for the decile analysis. It should look like a staircase. So something like this, a nice, beautiful, perfect staircase. Yeah, this looks like shit compared to that. So, basically the earlier stream, I got the filter to work. So I'm filtering out all of those stocks that I don't want. But the result is that it's performing like shit. So, I'm going through and trying to improve things. And so this actually was really simple. So this is just dropping out all of the stocks that I don't want. And then, keeping the top 1,000 by volume. Does Koifin have an API? That shit has absolutely everything, including delisted stocks. Hey, that's a good tip. Let me look it up. For the new people watching, please subscribe and like the stream. That helps me out a lot. Go to the GitHub, check out the code. You can do the same thing I'm doing. Under 50 lines of code, you can create a model and do basically all sorts of tests for it, including this decile analysis, and you get all of these metrics out. And then you could also do things like this walk forward analysis here. You could really robustly test your model. So download it. Let me know how it goes. Let me know how I can improve it, what you find useful, what other things you'd like to see added in. And finally, star the GitHub, watch the GitHub, and follow me on GitHub. All those things really help me out. Helps raise my coding profile, helps me get coding gigs, freelance gigs, and coding jobs. So please do that. So let's look at Koyfin. Comprehensive financial data analysis, modern investment platform. Sign up for free. Okay. I hate signing up. Let's see. How does Koyfin API work? What does the free tier include? And how much does the paid tier cost? Before I sign up, let's see. So we have that here. Let's go through and look at, so we've got the universe data. Let's go back here and see what's missing in the universe data in universe 6. So if I do Python 3, let's do pandas, let's do get the universe. Here we want to get universe 6. Let's do get the fundamentals, and let's look at the missing tickers. And okay, got them. Let's look at them. Missing tickers. Holy shit, that's a lot of tickers. So if I do that, if I do basically the same universe as universe 1, but drop out all the stocks that I don't want before, that's not going to work. But that's not going to work for incorporating fundamental features. So basically, if I want to incorporate fundamental features, I have two options. I could find better data, which has fundamental features for everything. Hey, Assassin Ninja, you sound scary. I don't want to run into you in real life. I wonder how good AI is scraping something like Koyfin now. Probably really good. I mean, I scraped the Edgar database. I scraped... Oh, that wasn't scraping. That was basically data processing to isolate the stocks I wanted. Common stock, ADR, and REITs. Let's see. So what's Koyfin? Koyfin does not offer an API at all. They do not allow users to get any type of data, blah, 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 blah. As they put it, they are in the API business. Well, Koyfin is in the analytics business. Okay, Koyfin does not provide user-facing data. Yeah, we get it. They don't have an API. Free tier includes global stock screener with multiple screening templates, multiple watch lists, portfolio tools, 2 years of financials, 1 year of forward estimates, advanced charting, blah, 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 blah. All right, let's go look at it. But it's taking forever to load, so I don't know what their deal is. Okay, so the next thing I want to do is turn Model 12 back on in the Model Explorer. Okay, so Model 12's on, and the universe is now 6. So this is the same universe that Model 12 was already using, but I'm dropping out everything that's not common stock, real estate investment trust, or a foreign listed stock. So Explorers, let's do Python 3, Model Explorer, and let's see how that does. So what do I want to do now? Let me think. Okay, let's look at the improvements I need to do. So if I go back to the PowerPoint, no, pull up the damn PowerPoint, market research. Here are my to-dos. So, oh, and I have more to-dos up here. I have even, but this is kind of outdated. Yeah, the combinatorial purge cross-step validation, that turned out to be a huge pain in the ass. There's all sorts of mismatches in the versions of the Python packages I'm using. So I'm not sure if that's going to work, or if it does work, you know, I don't even know how that's going to work. So, yeah. All right, so what do I want to do? Add fundamental features. I'm trying to see if I could incorporate them. If I could define a universe so that the things that aren't included in the fundamental data set are dropped out, that's possible. Universe 5 got close to that, but Universe 5 was cutting out all sorts of data because I had this argument here. So there's something wrong with when I give min history days. So Oh, here I took out min history days, so let's turn universe 5 back on, and let's pull that. All right, so this is the model. Analysis, don't want that. Explorers, so let's do Universe Explorer. Let me make sure this is saved. Yep, good to go. So it's getting Universe 5, except now I don't give them in history days. And I need to troubleshoot, so let's add a to-do here. Troubleshoot. Oh, not there. Add here. Troubleshoot problem with min history days input to advanced stats filter. Okay, and I want to see, what's the deal with that. So this is getting the universe, model training, we're up to 10, I'm doing 50 trials. So fundamental data, I need to hold off on that until I can figure out a way to define a universe that's not excluding anything or get a better fundamental data source. I built a keyboard that I think can rival the sound of your stream keyboard, lol. I've been typing stuff just for the sake of it all day. Hey, that's pretty good. It might be that, it might just be the keyboard, but it's also that, maybe it's the mic. I really think it has something to do with the mic, because when I'm typing on the keys like this, it sounds, I don't know, fine, but not that great. But I don't know, the mic must be right next to the keyboard or something, because I think that's why it sounds good. Anyway, you should sell it. Don't they sell people who are into keyboards like you? Don't you guys sell keyboards on Etsy? You can buy like a nice premium keyboard on Etsy. You should sell it. I might buy it, but you said it costs a lot of money to make. Anyway, congratulations on the good keyboard. See if anyone in the stream wants to buy it. There's 7 people right now. Let me try signing up to this guy for free. I'm kind of confused on if they have data or not I can download, or if they, if this is just in a web app. All right, so let me think. The next thing, I think your mic is dropping the high frequencies and making it sound thockier. It's doing something. It's doing something that makes it sound really nice. I have no idea what, because it sounds. I've listened to the streams and it definitely sounds better on the stream than it does in real life. What the reason for that is, I do not know. Okay, so what do I want to do? I really just want to see what the output of this model is. Okay, so good, that guy finally finished. Whoa, mean rank I see 0.0015. Okay, so now when I drop out those stocks, it performs terribly. Here's the feature importance. So it might be that I'm including too many features, but I have no idea why this is performing so poorly. You see that some things like regime 60 day is way more important than the other features. Look at this. So, oh man, so you can see obviously for some reason like February 23 to May 24, it's not including anything. So there's something wrong with that filter, I think. And then afterwards, I guess it does here for the short time period. Oh, well, that is just doing well on the bounce back from the tariff drop. Yeah, so what's the cause of that? I didn't do that much to build it. I just swapped the switches and keycaps. I do hack my keyboard firmware for really personalized features. Like what? Do you ever use those keyboards where it's like 2 separate keyboards in one? Those look cool. Okay, so Model 12 using same universe as 1 with only common stocks, REITs, and common stocks, REITs, and ADRs. Lowercase s. Model performs obviously worse. So let's put that in. Did I cancel out of the plot? No. Or yeah, I did. Model obviously is substantially worse. I've used those, but most of them are ortholinear, so it's hard. What does ortholinear mean? This guy doesn't want to let me make an account. I don't know, the AI summary didn't pop up. Ortholinear keyboard features a grid-like key arrangement where keys are aligned in straight, vertical, and horizontal. Whoa. I don't like that. Minimize finger travel. I don't know. That would be hard to get used to. I have a feature where you can program a key combo to trigger a layer change, which will revert the base layer when you release the first key in the combo. I don't know what that means. What is a layer change? What is the base layer? What does it mean to revert the base layer? All right, let's think. So model's obviously substantially worse. Oh man, my eyes are dry. That's because I just smoked a cigar. Cigars really dry me out. Model is obviously substantially worse. This universe is the same exact universe as universe 1, but with the stocks, but with everything dropped out except common stock, ADR, common stock, ADR, and REIT. Yeah, so what the hell? So there's something wrong in my filter that I'm using. I know that because let's just run that again so I can get the evidence. So I have this code which gives me all tickers which are common stock, REIT, or ADR. I then use this in what do I call that filter? So clean analysis, price filter, advanced stats filter, security type filter. In security type filter, to filter out everything except common stocks, REITs, or ADRs from my universe. However, when I get the universe, using this filter, there are many months in which no stocks exist in the universe. I can tell I have determined this to be the case because stocks exist in the universe. I've determined this to be the case because I see in my model analysis plot that it flatlines for quite some time. What is the cause of this error? Of course, there should always be common stocks, REITs and ADRs, which satisfy the other filters at every point in time I'm pulling the universe. And this is happening at the first of every month. Okay, the filters, I've included the filters I'm using for reference. Okay, so what do the filters look like? Let's go down here, copy, paste it down here. So if you just tuned in, please subscribe, like the stream, go to the GitHub, download the code, let me know how it works. You can do everything that I'm doing in under 50 lines of code. It helps me out if you star the repository, watch the repository, and follow me on GitHub. So now we need to give it the files. So add files, scripts, advanced model, no, clean analysis. So we want to give it clean analysis, and oh, this other script is in data retrieval. Okay, so data retrieval, fetch symbols, get valid tickers. This one, give it that guy. Then let's also give it scripts, clean analysis. Okay. Here's the output for the model again. So get rid of this. Lots of the features are performing quite poorly. Now we have this. Yeah, so again, we see flat line. Basically, the data has completely dropped out. But now, yeah, I don't really understand this at all. Oh, I forgot to include this plot. Okay, that's fine. I can put this in the PowerPoint because it's nice to have for reference. So let's move this guy up. Let's move this guy up, over, make it bigger. Make it a little bit smaller. Okay, so what else do I have to do? So I have to implement fundamental features, but it's looking like my data set's not going to be good enough. A layer remaps the keys on the... Oh, okay. So you can make it do whatever you want, basically. Switch over to layer 2. Now the keys are doing a completely different thing. Switch back to layer 1. They're doing the base thing. So I make MJ Cluio. What is... Oh, the keys. Into a numpad, for example. I can do everything, including the move the mouse without moving my wrists. You are a true keyboard hacker guy. That's crazy. But it's always cool. That's always the ideal, right, for being a coder. You're a coder in Toronto, is that right? Or am I mixing up the stream viewers? But I think that's right. You're a coder for a bank in Toronto. All right, what do I want to do now? Yeah, I basically have to figure out what's wrong. Implementing fundamental features, I'm either going to have to get a universe which only has fundamental features, or I'm going to have to get a better data source for the fundamental features. So that's the issue with this. I can redo the analysis, dropping all the features, because I wasn't dropping the features for different time periods, just one time period. Maybe I can get the correlation matrix. I mean, that's going to be huge, but maybe I can just look at how it looks with all features. So let's go to Model Explorer, get feature correlation matrix. Problem is it's going to be enormous, but that's okay. So first, I'm doing the features, engine, non-feature keys. Okay, so I just want to change how I'm doing the features. So I'll copy this, and let's add a new flag. We're going to say get correlation matrix, all features. Yeah, oh, I nailed it. Yeah, so anyway, that's useful for you because you're like a pro, you're literally a pro coder. Um, get correlation matrix, all features. Well, yeah, that does sound exactly like a software engineer. Um, and that's always what everyone talks about is the ideal, right? Is ideally, if you're a true coder, if you're a true serious coder, you don't need a mouse. But that's always been so hard for me to do. I always think this is a mouse is so efficient and elegant. It's just a thing you move around. I'm a big fan of the mouse. Every time I try to do that and just use keyboard shortcuts, it always is so slow, such a pain in the ass, but it looks cool and it is efficient if you actually can use it well. You can, not needing to transition over to a mouse is very efficient, but yeah, I've never been able to do it. So hats off to you, the true coder. All right, so now let's do if get correlation matrix all features is equal to true. Let's first get the features, then pass them in. Non-feature keys. Where is that? Correlation. Model, universe data, features, engine, drop. Okay, so I'm going to do the same thing actually as all of this right after I define the features. I use Vim for VS Code. I hate the mouse. My coworkers think I'm a wizard on screen share. That's what that's what I'm always envious of people who are really good at Vim, because it is cool. All right, now let's drop out those guys. And then I'm gonna go up to model 12 and get the features as they're all designed there, and then we'll have the correlation matrix for all features. Okay, so when's it finished getting the features here? Here, paste it in. Now let's turn that guy on and turn everything else off. Good to go. Get correlation matrix all features. Make sure that's what I called this. Get correlation matrix all features. All right, save this and let's run it. So what if I do the correlation matrix with every single feature? Our Lord and Savior Vim. I've always got time to talk about Vim. I like Vim, but the guys at my work don't. Oh, that's gonna just give an error. The guys at my work don't like Vim. They like what's that other one? What's that one that's not Vim? Damn, I can't remember. It's the one where you have to like write Control W or Control X. Vim, you do colon W, or you do I to start writing, then colon. I think you do colon W and then colon Q to quit. Anyway, so let's do Model Explorer. Now it's gonna get the correlation matrix. So, universe data is not defined. Universe data. So universe data is equal to that guy. Oh, universe data. So switch universe back to 1. Paste it up at the top. Emacs. Yeah, I hate that shit. Months to set up? Good. That's just what I'll say to my coworkers. Guys, that takes months to set up, though. Oh, they'll think I'm some expert or something. All right. I haven't dared try out Emacs yet, but supposedly it's more powerful. Oh, well, they'll just hit me back with that. They'll tell me it's more powerful. Um, yeah, anyway, I don't like it. It always confuses me. The interface comes up and I go, what the fuck is this? So here's the correlation matrix when I was only using 20-day features. The problem is I'm using, so 20-day features are just like one feature length. So I tried doing an analysis where I remove these one by one and see what's highly correlated. And if I remove it, is it useful? Also, Sir Night Night, who knows all sorts of stuff about these models, he tunes into the streams a lot, and he says really I should be able to what? Oh, he says I should be able to trim the features down, but every time I try trimming the features down, that makes the model perform worse. So um, that's not going to really work for me. Um, I have another idea for a model, which is do a different model for every sector and then use the portfolio level model to see how it's doing for the sectors. So now it's getting the features, and then it's going to do the correlation matrix. So these are features, but it's only when I'm using 20-day features. And this isn't the only thing I'm using. I'm using 20-day features. I think I'm using, what am I doing? I'm doing 20 days for short term, 60 days for medium term, 200 days for long term. So it's going to be this, but each axis will have 3 times the size. Uh, so that's going to be a lot, but really I need to figure out, it's there's a high probability that, like, for instance, 20-day returns are correlated with 60-day returns, or 60-day returns are correlated with 200-day returns. And so I have way too many features I'm putting into the model. So I need to trim it down and improve the features that I'm using. Um, but that's just kind of taking a while. So I said it before, I'll say it again. If you just tuned in, please subscribe, like the stream, go to the GitHub, download the code. You could do everything in under 50 lines of code. Oh my gosh, that's madness. It's not even, yeah, it's passing out. Holy shit, that is way too much to look at. Um, uh, yeah. I mean, this is just madness. Yeah, so that's not gonna work. I need to figure out a better way to do this. I probably am not gonna be able to look at it manually. Um. Oh yeah, but then go to the GitHub, start the GitHub, watch the GitHub, and follow me on GitHub. All that stuff really helps me out a lot, so I'd appreciate it. Um. Yeah. So. Um. We need to. Let's just say down here, correlation matrix with all features is unreadable. And then let's go back to Claude. I forgot I was asking it, how come it's not including data? What's the issue here? The issue is almost certainly a ticker mismatch between your price data and your valid ticker list over time. Security type filter loads a static point-in-time set of valid tickers from valid equity tickers.feather, which was built from your symbols.feather, but price data spans many years. As you go back in time, the tickers and the price data increasingly diverge from the tickers in your current metadata because of delistings. I've accounted for all of this. Eventually, for some historical months, none of the tickers in the price data match your valid data set. This isn't what's happening. You can confirm this with a quick diagnostic. Add this right after the security type filter applies in get universe for month, or run it standalone. Okay. So let's go back to clean analysis, security type filter. After it applies, run this guy. Price tickers in window equals set. Not working df. df. Oh. Working df. I don't have working df. It's just df. Okay, so let's do all this before. New df. Okay, I'll say working df actually. Then we'll say here working df. And then here I'll say return working df. I haven't dared try out. Oh, I already read that. All right, so let's exit out of this. We can say it's unreadable. Damn it, I copied something else. That's fine. So let's do the Universe Explorer again and see what that output is. Okay, that shit's not gonna work. So Python 3, Universe Explorer. Very cool. Now let's see what the deal is. No attribute filters, security type filter. Security type filter has no attribute filters. What line is that? 273 and apply. Oh, so it should be in the universe, not in, so damn it. Okay. Let's go back to this, copy, get universe for month. What's wrong, buddy? Why are you whining? Okay, now let's run it. Let's see the output. So it's working so far. Yeah, let's just watch this and see if it prints something out. If it prints something out, we're having an ooh. No. Working. Huh. Alright, so it looks like it has something for every month. Hey, Yusuf. Sorry, Yusuf. How are you? What's going on in your world? I'm trying to get my stock market model to work. And every time I try to fix it, it does worse. So I'm having all sorts of trouble. But I really think if I just keep hitting my head against the wall, a good model will pop out eventually. I just need to have a good attitude and work hard at it. So this is almost done. It's working. So 2023, though, it wasn't working. So let's see. We're in 2021. We should get to 2023 soon. No errors so far. Still no errors. And it should be done soon. Still no errors. We're in 2024. Up to 2025. Still no errors. Thanks, Yusuf. I appreciate it. 2026, no errors. So let's see. So we don't have any errors. Okay, so we can update. So I added the diagnostic, and it turns out I am actually getting tickers for every month. Why does the model output plot look like this? Why does long short flatline? And I guess I know actually, because sometimes I bet sometimes there's not going to be anything in that top or bottom decile. And it gave pretty different looking plots both times. So that's kind of a question too. So let's see what it says. It's kind of a conundrum here. Yeah, so let's see. So yeah, I gave it the diagnostic plot. Very good. Yeah, so I'm looking more into how to improve the model. I want to squeeze some more performance out of the model. Adding these universe filters is really giving me a lot of trouble. Adding sectors didn't improve anything at all. I thought both of these would improve the model. So now I really need to look into what's the issue with the model. How can I improve it? I'm not able to implement fundamental features right now because I don't have enough data on them. I'm missing fundamental features for a bunch of tickers. So that's causing an issue as well. Hey, Panda Plutonian, I just joined. Which coding? Yep, Claude Code. Yeah, so these are the issues I'm having. I'm stuck on this right now. Let's see. Come on, tell me. Yeah, but anyway, I'm having a lot of trouble with this. So that's going to be the end of the stream for today. In the future, I'm going to keep working on this. I stream on this project every single day, so subscribe to follow along, like the stream. That stuff helps me a lot. Go to the GitHub, download the code, try it out for yourself. Let me know how I can improve it. Start the GitHub, watch the GitHub, follow me on GitHub. All of that stuff really helps me out a lot. I'd really appreciate it. Have a good rest of your night. That's it for me. Adios. Of trouble with this. So that's going to be the end of the stream for today. In the future, I'm going to keep working on this. I stream on this project every single day, so subscribe to follow along, like the stream. That stuff helps me a lot. Go to the GitHub, download the code, try